this. Thanks, everyone. Thanks for coming, and thanks to Wasif for the opportunity to speak to all the awesome people here. My talk today is about Brownfield and legacy continuous delivery, and it's based on a real experience that I've been through recently with one of my clients. And it was an exciting journey that I wanted to share with everyone because there is always this old system somewhere at some organization that needs some love. So I'll ask you a couple of questions just to understand what's your background with dealing with Brownfield and legacy applications. How many of you are doing any continuous delivery and continuous integration for a system that's more than 2 years old? More than 5 years old, keep your hands up. More than 10 years old, keep your hands up. 15? 20? 20 years? No hands up. All right, so the system I'll be talking about is about 20 years old. That's an exciting story. First of all, let me properly introduce myself. So my name is Bishoy Damien. I'm a principal consultant at Dot Labs, a company based here in Sydney. We specialize in DevOps, ALM, and cloud integration, migration, specifically for Microsoft products. That's my contact information if you want to get back to me on any of the information I'll share in this talk. I'm also an Azure insider. So first things first, let's sort out what Brownfield means versus Greenfield. Most of the time, Greenfield means you have an opportunity to do a fun new project. So brand new technology stack, brand new tools, brand new backlog and everything. And when you're talking about new technology, with the reintroduction of CLI tools with most of the new technology stacks, it's very easy to get a continuous build, a continuous deployment running. For example, Angular have a CLI, for example, that you can use to do builds and most of the continuous integration stuff. But old tools, most of them didn't even consider something like an automated or unattended build. And they are mostly was geared towards RAD development, rapid application development. And you would be mostly dependent on an IDE to do a lot of these tasks. Have anyone seen or familiar with the very famous XKCD cartoon that two developers are fighting and they say, yeah, and they say that the code is compiling. So yeah, that was mostly the experience back then. So Brownfield is mostly a bit older project that's been going for a few years. Mature technology, you would have the tools, enough support for the tools to help you get a continuous integration, continuous deployment happening, but sometimes you would have some rough edges that you have to work around. For example, .NET had from the beginning, from like 10 or so years ago, from the beginning they had MS Build. Java, they had Ant and other build systems and Maven. So since quite some time, these tools existed that would help you get a build running. And deployments, they had MSI for as long as probably Windows existed and other tools that can deploy these applications. But when you talk about legacy versus, in contrast, you're talking about systems that have a very long shelf time. Believe it or not, some banks to this day and age have mainframe and systems running in COBOL and terminals. And they occasionally have to maintain these systems and keep them updated. For example, legislation's changed and they have to do some tax calculation differently. You need to make a change to the system. And it's very old and it's very rare to find to find talent to work on these systems. But it's also very challenging to use any new technologies or tools with these systems as well. It's a very closed ecosystem of very old tools that are no longer maintained, and you need to keep them happy by not trying to make a substantial shift in how you use them. when talking about these systems, they are vital to the organizations. They cannot replace them very easily. Talking about an accounting and ledger system, for example, that's been developed across 5 or so years, it's an investment that the business cannot get rid of very easily with a new system, a new shiny platform. The technology is obsolete. You have to kind of be very careful how to deal with it, but there's also a substantial cost associated with it, mostly called enterprise systems. Yeah. But they are critical, and there is no way around using it. How do I get a legacy system to be an agile, in an agile process and continuously delivered? And this is the discovery that I've made. This is the short summary that I'll explore in details. So first things first, it's mostly a people and change management job more than a technology and technical job. You're jumping into an organization and a team that's been working on this project for at least more than 10 years. Some of these developers are not up to date with the new technologies, the new methodologies, and the new processes, and you need to educate. In the organization itself, there is a huge background of decisions that's been made along the lines of developing that solution that you need to kind of understand why they do things the way they do it, how they are communicating, and how the team structure, who is doing the decision making. You need to understand the organization structure around this team and around the solution, around this project. You need to manage the change. You don't just go in fully armed and blow the thing out. You need to kind of be careful. How do I introduce this change? What kind of risks am I introducing with this change? And how do I test and manage the risks as I go? You need to mentor the team, as I said. Mostly you're talking about very senior developers. I've been working with a developer who's 50-something and he's soon to retire, and he's awesome. I've been mind blown by the amount of knowledge and professionalism that he had. And I would definitely love to work with that person again. But again, we're talking about knowledge that he does not possess in a new technologies and new processes. And I needed to mentor and teach, why do we do agile? How do we do backlog development? And how do we do continuous integration? What it means to do continuous integration? Why are we doing automated tests? How are we using automated, or how do we introduce automated tests in a system like this? So we have to go through all these learning one by one. Change the process, but again, change the process comes after you understand the organization, manage the change and the risk associated with it, and mentor the team. So changing the process comes very slowly as well. You might wanna make sure that you have milestones spread out on the project that can possess less risk to the team going into these, and less risk to the business. And go for the quick wins first, the low-hanging fruit. That works very well. And learn the tools. I mean, I didn't know anything about the technology of that project before. I haven't used it before. I mean, I've probably listened or heard the name a couple of times, like Power Builder. I know Power Builder was some sort of a programming language somewhere, but I haven't used it. So I had to kind of go and learn something that's a technology that's more than 20 years old, and learn some of its inner tools and tricks to be able to help those developers adapt a continuous integration, continuous delivery platform or process. So about the organization, this is the most helpful quote that I can tell you. Conway's Law. Anyone familiar with Conway's Law? Yeah. So I'll try to tell you a little bit why Conway's Law is important. Within a team that's been developing and maintaining a system of 20 years old, there has been a background of decision making that you don't know. And to understand why these decisions were made at the time they were made and how they were made, you need to understand what's the organization communication channels around these. Who's the decision maker? Who's the catalysts in the team? And how the decisions are being made. All these communication channels, once you understand, you need to be able to manage that change. That's the next step. How, like for example, if I go and talk to developers about something and they dismiss it as that's too risky, or that's probably going to lead us into trouble in the future, and we hit a roadblock, how do I get off that roadblock? What's the next step? Who do I need to talk to if communication is blocked with the development team? How do I make things smooth? How do I shift gears from talking to stakeholders and talking to the technical team? Understanding how the organization works and who to communicate to for specific topics will save you a lot of time. So make your focus in the first week is to understand the communication channels, the organization structure, and the people around it. Change management and people. So anyone have seen this diagram before? Yeah? That's John Fisher, Personal Change Process, 1999 to 2012. So this is kind of a standard process of what people go through when they go into a change from their comfort zone. It's very helpful. It's not technical. It's something that our personality leans to kind of go through this wave of feelings and emotions around change. I have a comfort zone, and when someone tries to push me out of comfort zone, how I react is mostly different than other people, but there is some sort of a mid-range or a standard reactions that you kind of learn. Okay, so they start by having an anxiety, then they jump into happiness, yeah, we're doing something new, then they start getting frustrated, and then they feel some guilt, why am I doing this? And then some depression if it gets worse, and then they start moving forward and adapting to the new comfort zone. Again, most of the time what helped me around dealing with these situations is actively listening to the developers. Most of the time they are trying to tell me something that's not directly said. For example, no, this is not going to work. Why it's not going to work? Because you did X, Y, Z before and didn't. So tell me, how did you do X and Y and Z? I'm trying to dig deeper and listen to what they're trying to tell me. Why do they think that it's not going to work? Explaining. So have some empathy around these guys. These guys have been trying to tell you the problem, the problem from their perspective. So when you actively listen, have some empathy and try to tell them that you feel what they want to say. Explain. So explain a lot. Do go deeper into the mechanics of how things work. Why are we doing branching and merging? Why are we doing release branches? Why are we doing this and that? You need to explain the inner works of things to make sure that they resonate the benefit of doing that, not just they are following. Take them into the journey. The process. When we talk about most of the legacy systems, we're talking about people have been working in a process, mostly waterfall. Agile is fairly new. I mean, Agile was introduced in 2001, probably, or formalized in 2001. Adoption actually started from 2011, like wide adoption started from 2011. And in order to shift that process, I needed to kind of do a lot of mentoring around Agile. How do we do sprints? How do we push backlog items? And that leads into other things, like when we talk about branching, it will flow, the conversation flows from sprints and backlog items and work items. And I use the maturity model to show them where we are and where we are going. And that maturity model relates a lot to the software development lifecycle. So the maturity model is, all right, we'll start with Agile development. We'll try to automate planning and coding. We go into continuous integration, and continuous integration will give us a little bit of build and test automation. And then we will go into continuous delivery, and this will give us a little bit of test of release automation. Then maybe we can do DevOps and do infrastructure as code and continuous monitoring. And this maturity model, baby steps, if you want to call it, helps a lot visualize what needs to be done in relation to the old process that they used. In terms of tools, my challenge with the tools was mostly around figuring out what to use to do this task. Like, for example, I want to run an automated unit test. How do I do that? How do I automate a unit test for something that's not a web app, for example? It's a Windows app. And I needed to learn a few libraries and a few APIs in Windows itself, like automation, UI automation APIs in Windows itself, and if there is any libraries that help with that. I needed to dig deeper into command line tools. These are the most helpful bits in continuous integrations. Like, is there a way to execute this build without using that IDE that you're using? And what kind of parameters? Where is the documentation? Sometimes there's undocumented stuff. The documentation have gone away. You can't find it anymore unless you're digging deeper into Code Project and other very old forums to find that information. So unattended tools is your best friend here, and mostly you will find it in command line tools, DLL libraries. Sometimes I had to kind of reverse engineer some of the IDE DLLs to kind of understand the methods that gets run in a build and see if I can invoke these DLL methods from my own executable or my own CLI, for example, to do this without opening an IDE. Sometimes I had issues with the licensing, but that's irrelevant to the talk. But from an automation, continuous integration, continuous deployment automation tools are very transparent to what happens in a build. I kind of scripted everything and put it in a batch script or a PowerShell script or a bunch of these connected together, and the automation tools kind of just execute this, that's your build. Because there is nothing in the modern continuous integration, continuous deployment tools that supports or understand these legacy systems and legacy technologies. We moved the team to use Git. Mostly they have been using CVS and SVN. And the reason behind it is that I wanted them to adopt the agile process. And to adopt the agile process, they need to have multiple streams of work simultaneously. Like, we're stabilizing a release, but we're also working on new features in this sprint. And we have this test branch or release branch going off to the testers to test and stabilize, but we also need to maintain a trunk for developers to work on. We need feature branches in isolation to those two, and we need the master branch to reflect productions to roll back or roll forward, and we kind of had to migrate them over. So overall, it was a very easy sell once I demonstrated the differences conceptually and practically how to use Git. But again, it depends on teaching. You need to be a great teacher and mentor for these for these teams to allow them to shift gears into those new tools, and you need to support them a lot through the transition. Branching. I didn't want to deviate from a standard format. I know a lot of people using Git have their own kind of branching schema. There is a few standard ones, but the most effective one and easy to understand was the Git flow, and it allowed them to start new features, have a trunk for constant changes, and have release branches for stabilization separately from their trunk, and be able to work on hot fixes separately from a stable production branch. We did use that to map an end-to-end solution from where is my repository, and for each repository we have the bunch of branches we've seen into the branching workflow, and map each branching schema into an environment. For example, if you're working on a feature branch, you can get a preview environment where you can talk to the stakeholders and showcase your new feature without affecting other branches or other environments. If you are working on a dev branch, you get an integration environment where your automated tests will be run on, and it's not usable by anyone other than just automated tests. If you branch off into a release branch, you get a testing environment, and then your code is deployed for the testers, and they own this environment. They will give you some bugs, you fix it in that branch, it gets deployed again and update that environment. So they kind of resonated the relationship between different environments, different branching models, and Git flow kind of was mature enough to reflect a fully fledged software development lifecycle in these branches. Versioning, we adapted SymVer or semantic versioning, basically because semantic versioning had a lot of had a very good way to express metadata in the version number, other than just major, minor, and patch. And we use that metadata to describe the branches that are coming, that this build is coming off from. I'll give you an example. So this text is coming off the semantic versioning website, which is semver.org, I believe. So major versions, we need to communicate major version changes when we have incompatible changes. We need to communicate minor version changes when you have backward compatible changes. You're adding a feature or fixing a bug, but it's backward compatible. And you can do a patch when you're doing just bug fixes or patches. And labels when you're doing pre-releases or branches. So, for example, a feature gets a label if it's coming off a feature branch. That's a production release, and that's a hotfix release. So we communicated branches and streams of work along with the version number with semantic versioning. In terms of continuous integration, we've examined some tools, but we've mostly settled on TeamCity, mainly because TeamCity had a support for a wide range of technologies and tools. It's an open platform, had a great API covering, so we can automate with our own dashboards and tools. And we've used TeamCity mainly to build the projects, analyze the code base if we had any analysis tools, run the automated tests, do the packaging of artifacts, and then publish those artifacts somewhere on a feed that can be pulled from. And we've settled on Octopus Deploy for automated deployment. Basically, again, Octopus Deploy has a great integration with TeamCity. They both work together very nicely. Octopus Deploy supports a lot of target environments and a lot of deployment models. For example, I can SSH to a Linux VM, or I can remote through a tentacle to a Windows VM, or I can deploy to a cloud service in Azure. They're all seamlessly integrated within the same place. Also, within TeamCity to Octopus Deploy transition for deployment and release automation is seamless. There is a plugin we install on TeamCity, and it allows us to push new releases on Octopus Deploy. One thing I really love about Octopus Deploy, though, is that the problem domain of release management is something that's represented very, very clearly in Octopus Deploy. So from navigating environments and targets within these environments, declaring and configuring projects with their channels, variables, and steps, creating releases within these projects, and then deploying those releases. So I love the clarity of that deployment model, and within the organization, the less complex the solution you have, the more acceptance you will see, especially in an older or a legacy project. When things are easy to explain, things get accepted pretty much without a lot of resistance. But if you go through a lot of complexity and you have a challenge of explaining the tools and how they work, and a challenge of getting people up to speed and using these tools, then the problem becomes bigger. So back to that maturity model, we've covered builds and tests with TeamCity. We've covered releases and deployments with Octopus Deploy. We didn't get there yet to the DevOps scale of operating the stuff, but at least we've moved from a waterfall model all the way up to continuous delivery, and that was quite good enough, actually, substantially better than what was being done. Something I really love about Octopus Deploy too, that I want to share with you, is the channels and life cycles. So it's very, very, very easy to shoot yourself in the foot if you're using tools that connect and control your production environments, and managing a governance, a tight governance over those tools is important. So channels in Octopus Deploy, for example, allowed us to define different channel per stream of work. Like a channel for development work, including features, a channel for releases to testing environments, and a channel for releases to production environment, including staging and production and blue-green deployments. And within those channels, I have lifecycle to control, all right, if this package coming with this particular version number format goes into that particular channel, like dev channel, it needs to conform to this particular lifecycle, like a development lifecycle, where it can be deployed to an environment called development and an environment called preview, but it cannot be promoted across to other environments like testing or production. So it allowed a lot of control around what sort of releases go to which environment through channels and life cycles. So in summary, very quickly, understand the organization and the communication structure within that organization and the decision makers. Manage the change and the risk associated with it. Mentor the team. You'll have to teach a lot. And change the process slowly and learn the tools around the technology that you're trying to do. And legacy applications within this strategy wouldn't be any more challenging than any regular greenfield or brownfield application. Questions?
How long did it take you to get to that stage from start to end?
So it's hard to tell. I mean, from start to finish, we did go through multiple phases. First phase was purely training. So there is a lot of new subjects and a lot of new tools, and I needed to kind of bring them up to speed with source control tools like Git, continuous integration tools like TeamCity, and continuous deployment tools like Octopus Deploy. So we spent a couple of weeks teaching and going through workshops, hands-on workshops, not in the context of their project at all, but in the context of understanding the processes, the new process, CI and CD, and the new tools, and getting their hands dirty and practicing those tools in the context of a very small proof of concept. Once we get through this training phase, we started approaching the existing code base. What is the quickest win we can do? For example, we started doing continuous integration on the existing source control, or should we start migrating the source control? And these things takes time. The other thing that you need to be aware of is that the impact of this change on the existing backlog and existing work. Most of the time, the system is there, is being actively maintained, and there is demands for new features, and we kind of need to manage this change along the lines of also delivering value for the business. More questions?
So what's the benefits of having like development branch and release branch, and development go only to development environment, and when you want to do this environment, there's a release branch?
Very good question. I had to answer that question 5 times at least in one day. So a development branch is your continuous integration branch, is where your features, when they are mature enough to merge into that trunk and to integrate with the other features developed in isolation, that's your integration branch. This is where those features merge into being built and tested together. You might have your code healthy and building and green, and your tests are passing. Someone else's feature is green and tests are passing. But when they merge together, you kind of could find bugs that didn't exist in those code bases in isolation. So your dev branch is where you integrate those features together and test them. Your release branch on the other side is where you say, okay, I think I have enough features to go into the next release to production, but we need to stabilize. I can't merge any more features into these specific set of features. So you branch them off your trunk. You allow your developers to commit other features into the trunk because you branched off, and you get the testers to start testing on that release branch and stabilize. They find bugs, you fix bugs in the release branch until you stabilize that release branch, and you're satisfied that this can go to production. And at that point in time, you just merge it into your master and it goes to your staging and then goes to your production.
But then we promote more of like a big releases, big bulky releases.
No, not at all. I mean, you're talking about probably 2-3 sprints can go into release branch, for example. One within the same sprint or within those 2-3 sprints, you're quite updating your dev branch on a daily basis. Again, that process might not work for a small team on a lean startup, or there is a lot of ceremony, I give it that, in Git flow, but this ceremony works well for enterprise for the enterprise and the big corporates, where they need to manage deliverables very tightly, and they have milestones and they have deliverables every month, every quarter, every 6 months. They have a release schedule that might not be every sprint.
You mentioned low-hanging fruit to fix that first, and then can you just talk about what was one of the easier things to change in the legacy system and what was more difficult?
Yeah, one of the very low-hanging fruits for me was to get a shift into Git as a source control change. That was the quickest change I could get done, because number one, it was very easy to kind of shift into another tool but using the same concept. You're pulling source code, you're making changes, and you're pushing that source code. And with some very simple training and hands-on workshop, within a week, we've been able to migrate across. The decision whether to take your history with you or not as well was kind of the main discussion topic. And once we get that decision made, there are tools already distributed with Git source control that allows you to import from other repositories. So that was a very quick thing. Any more questions?
Regards to Octopus deploy, which we use for continuous deployments, how did you make a statement for convincing your ops guys to install a Octopus agent on your prod servers, which could untar a package right from their on?
Yeah, look, it's not a highly regulated environment like ASX, so it's a corporate, yes, but it's not the CIA systems, for example. It was quite a conversation that this is a safe tool used by multiple clients, and there is even banks here, Commonwealth Bank, I think, uses Octopus Deploy, or other banks maybe, that are already using this, and they have certified that this is safe to be used. And the argument wasn't the hardest part to go through, but the actual training of how to use the tool and what the tool is doing, what is contained in these agents, for example, and how they operate, what are the security around the communication channel between that agent and back to the server. I had to explain most of that, yes, but the decision wasn't really that hard. All right.
Thank you, Vishal.
Thank you very much.